Yes, we are doing math. Okay. Hi everyone, today we're gonna speak about a topic case divisions, what they are, how we use them in math, and how to approach them to solve problems and equations efficiently. Case divisions are especially needed when dealing with functions and equations, especially different values of variables such as an absolute function or piecewise defined function. At the end of video, I believe that you'll gain a clear understanding of case divisions, especially the case second division, and how to approach them to solve questions and problems efficiently. So let's dive in. Okay, as I give an example, for write a sum or difference of multiple fractions equations, we just need to make them to a common denominator. They are partial equations. And to write a sum, we just need to make them a common denominator. So let's see. As in case this is sum, we just multiply them, x minus 1, 2x plus 1, and as we haven't any 2x plus 1 in there, we write like that, 2x plus 1 plus, then we haven't any x minus 1 in there, so we move to this to term, x minus 1. So writing the final equation, this is 2x squared minus x minus 1, and this is 3x. This is our final part. So we use partial equations to common denominator, but in some cases of algebra to calculus, we cannot do like that. So we do the reverse. We come to partial equations using common denominator. It means we come from 3x over 2x squared minus x minus 1 to partial equations 1 over x minus 1 plus 1 over 2x plus 1. We call this partial equations. And assuming them as an r of x, we can write the general formula as p of x dividing q of x, where every time the degree of the p of x is less than the q of x. So we can write like that. As you see, we can finalize this that every polynomial with real coefficients can be factored completely into linear and irreducible quadratic factors. That is, factors of the form ax plus b and ax squared plus bx plus c. B and c are real. For example, assume that x to the power of 4 minus 1. How do you solve that? We know it's the x squared minus 1 squared. So we know the formula a squared minus b squared, which is a minus b, a plus b. So in this equation we write like that, x to the power of 2 minus 1 and x to the power of 2 plus 1. So as you see, these are the partial equations. Case 2, the denominator is a product of a linear factors, some of which are repeated. Okay, suppose the complex factorization of q of x contains the linear factor x plus b repeated k times. That is, x plus b to the power of k is a factor of q of x. It means you have a 2 roots or 3 roots, and if this roots repeated k times, again considers a roots. So then corresponding to each such factor, the partial fraction decomposition for p of x over q of x contains a1 dividing x plus b plus a2 dividing x plus b squared plus blah 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 plus a k over x plus b to the power of k. Let's consider this example. X squared plus 1 dividing x multiplying x minus 1 to the power of 3. So we need to follow the rule in the case 2. I want to divide all of this part. We see that it's the x and x minus 1 to the power of 3. But we know that we have 3 functions, 3 equations in this only part. x minus 1, x minus 1, and again x minus 1. But we don't write like that. We write to the least to the most x minus 1 to the power of 1 is the first one. We need to follow to this path to reach this final goal, x minus 1 to the power of 3. So the first one, x minus 1 to the power of 1, we don't consider to write 1, you can. Second, we follow the path, consider this as a path to reach goal. Second one, x minus 1 to the power of 2, and the third one is x minus 1 to the power of 3. So let's combine all of that. We know that we just need to write x there plus x minus 1 there plus x minus 1 to the power of 2 there plus x minus 1 to the power of 3 there. But we don't know how to divide this part. So we write like alphabetic. A there, B there, C there, and D there. You can write A1, A2, A3, A4, but it's okay for writing like that for being easy. So, as a rule, we continue to write in the first equation I provided you. We just need to write what we haven't in this part. So, the first thing is that x and x minus 1 square. We see that there is an x there, so we need to multiply a with x minus 1 to the power of 3, which we haven't. Plus b, we haven't x there, x plus we haven't, we haven't x and x minus 1 to the power of 3. We have x minus 1. We left x minus 1 to the power of 3 dividing x minus 1, which is x minus 1 to the power of 2. Multiplying x minus 1 to the power of 2. We have x minus 1 to the power of 2. We don't have x minus 1 and the x. Plus b, we have x minus 1 to the power of 3. We don't have x. So, all of these must reach the x to the power of 2 plus 1. Let's divide them, open them. A, x minus 1 to the power of 3, x to the power of 3 minus 2x squared, 3 squared. Plus 3x minus 1 plus b x plus x squared minus 2x plus 1 plus c x squared minus x plus bx. So we see that. Okay, let's combine x squared to the same place. A plus b x to the power of 3 minus we have square there, we have square there and there. So we can write like c minus 2b and minus 3a. Multiplying x squared. So look, so we need to write plus. Yeah, it's minus 2b minus 3a plus ac. Okay, we also eliminate all of that. So we left only x one. 3 there plus x, 3a plus b minus c, and also plus b. So we have also there. So what we left, this one, minus 1 and only this, minus a. Okay, plus minus a equals x squared plus 1. Let's write like that. Multiplying part is x to the power of 3. At the final part, we haven't any power of the 3 of x. So this must be 0. Because we haven't, we just need to remove this part. But x squared, we have x squared and the result is 1. This part is 1. So all of these must be 1. Second part, x. You see we haven't any only 1 power of x, then this part also must be 0. 0. And the minus a, you see we have only without any variable, so this is a. Minus a equals to 1. We can get a easily. This is minus 1. So a equals minus b. So b equals to this part is 1. Then get the part minus 3a, which is 3 according to these functions, minus 2 plus c equals 1. This is 1 plus c equals 1. C equals 0. Then use this part. This is 0. We need to find d. D equals minus 3a plus b, which is minus 3 plus 1. This is minus 2, also minus 2, it's positive 2. We found a is minus 1, so this is minus 1 over x plus b 1 over x minus 1 plus c is 0, so this part is 0 dividing x minus 1 to the square. This is 0 plus b 2 over x minus 1 to the power of 3. So the final part of the common denominator to the partial equation is x squared plus 1 dividing x minus 1 to the power of 3 is equals minus 1 over x plus 1 over x minus 1 plus 2 over x minus 1 to the power of 3. So the case 2 of divisions, which is denominator to the partial equations, is named, classified like that. I hope you understand everything. Thank you.